Good morning, good afternoon, everybody. Hope everybody enjoyed my first video on the integer rules 1 and 2. So today we're going to go ahead and cover rules 3 and 4. But before we do that, we're going to go ahead and review what we learned with rules 1 and 2. So in our last video, we started talking about the integers rules 1 and 2, and we're going to take a look at some application to the rules here. Sometimes you may have problems where there's more than two sets of integers in order to solve a problem. So I'm going to show you two ways how to solve these kind of problems. The first and traditional way is to treat the problem left to right. So if we only have addition and subtraction problems, we're going to go ahead and evaluate every single part of the problem, two integers at a time, until we get to the end. Then later on, we're going to go ahead and try to combine the same signs and take one final step in the end. In my experience of teaching this material, half of my class likes left to right, half of my class likes same sign combined, as I call it. I prefer same sign combined. This way we gather all the signs of the same and then take that final step in the end. For now, let's go on and start traditionally with left to right. So we're going to look at 10 minus 12 first here. So again, sign directions, apply the sign direction so you know which rule you're going to use. So positive numbers and additions point to the right, negatives and subtractions point to the left. So we have a rule 2 going on here. So we got a 10 minus 12. So we're going to do big takeaway, small. 12 minus 10 is 2. Keep the sign from the larger integer. 12 is magnitudely larger. Make that a negative. Bring the rest of the problem down. So this way you treat every single part of the problem with the integer rules until you get to the end, and we'll have our final answer. Negative 2 points left. Addition pointed to the right. Subtraction points to the left here. We're going to handle negative 16 a little later on here. So we got negative 2 plus 4 here. So we have a left pointer and a right pointer. So we have the signs pointing in different directions. Rule 2. So 4 minus 2 is 2. Keep the sign from the larger integer. This case is 4 is magnitudely larger. It's positive. We're going to keep this as positive. Bring down minus 16. Positives point right. Subtractions point left. Again, rule 2. 16 minus 2 is 14. Keep the sign from the larger integer. In this case, it's the 16. It's sharing a minus sign. Our final answer is negative 14. Let's take a look at this one here. So we got minus 3 minus 4 plus 2. And minus and negatives can be interchanged with each other. So in this case here, we got this negative 3 minus 4 pointed to the left. That's rule 1 here. Sign directions are the same. So we're going to add them up here. 3 plus 4 is 7. Keep the sign you're working with. Bring down the next part of the problem here, and that's going to be the plus 2. Negative 7 points left, plus 2 points right. Here's a rule 2. 7 minus 2 is 5. Keep the sign from the larger integer. In this case, 7 is larger. It's sharing a minus sign. Our final answer is negative 5. So what I've done here is I treated these two problems left to right fashion with the integer rules until we get to the final answer. So this is one way to solve. I'm going to show you my other nifty way of solving these problems. It is called same sign combined. We're going to talk about that. Same sign combined is nothing more than adding up your wins, adding up your losses, and performing the final operation and to get a final answer. What is same sign combined? So what I'm going to look for here, I'm going to look for all my positives and my pluses first. So see, 10 is a positive here, so I'm going to underline that there. And plus 4. See, it doesn't matter the order how addition and subtraction is treated. Sometimes it's easier to do same sign combined. Sometimes it's left and right. It depends on what's going on in the problem. And it depends on your effort level and what you want to do with the problem. So in this case here, I have $10. I have another $4 here I'm going to obtain here. So 10 plus 4 is 14. Now I have a minus here, minus 12, and minus 16 here. Those are two same direction pointing of the signs here. So I'm going to go ahead and add up 12 and 16, and that should give me 28. Keep the sign that you're working with. So basically with same sign combined is I'm just applying rule 1 until I get to the final rule 2 here. And here's my final rule 2 because 14 points right, subtraction points left. We're going to subtract here. 28 minus 14 is 14. Keep the sign from the larger integer. Negative 14 final answer as we've gotten before. Now let's take a look at over here. So we have here, looks like a negative 3 or minus 3. Negative 3 minus 4. Looks like there's two losses here. And we have a plus 2 here. Let's bring that plus 2 down here. We can bring that here. And then minus 3 minus 4, that's going to be a negative 7. In this case here, we're going to be subtracting the 7. Remember, minus and negative are interchangeably used in mathematics. So now we have our final rule 2. Right pointer, left pointer, different directions. Rule 2, 7 minus 2 is 5. Keep the sign from the larger integer. So there are two methods here to solving integers if there's more than two sets of integers here. So you can go ahead and apply this to a wide variety of problems. We're eventually going to see 5, 6, 7 different polynomials with different signs and how we're going to handle those a little later on. All right, so there is integers rules 1 and 2. Let me go ahead and put up on the board here a couple examples for you to work on here to make sure you have a firm grip of this. And then we're going to take a look at rules 3 and 4 in a little bit. So I'm going to provide these examples here. I'm going to go ahead and pause the video. I'm going to go ahead and work on this here. That's fine, we can do that. Negative 12 plus 16 minus 18 plus 2. So go ahead and pause the video, work on this here, whatever method you prefer. All right, hopefully everybody got a chance to work on these examples. Let's go on and work on these problems here, whatever method you preferred you worked on here. I'm going to work it as same sign combined here. So I see I have a negative 12, negative 13, and negative 7, or minus 12, minus 13, minus 7. So what I'm going to do is I'm going to add up these losses here. So negative 12, so we're going to add up 12, 13, and 7. So it doesn't matter the order here. So I'm going to go ahead. 13 plus 7 is 20. Plus 12 is 32. So I got negative 32. That's my losses here. Add up all these together. You get negative 32. Bring down 7. Okay, here's your final rule 2. So 32 minus 7 is 25. We're going to go ahead and keep the sign from the larger integer, and it's negative 25 as our final answer. So if you would have also did this left to right, you'd have gotten that same negative 25. So let's see, 7 minus 12 here, we're going to do this real quickly here. 7 minus 12 is negative 5, and negative 5 minus 13 is negative 18, and negative 18 minus 7 is negative 25. So there's your left to right, and here's the same sign combined. Okay, let's go on and take a look at here. We got 16 as a positive. This is plus 16 plus 2. So here's your plus 18, positive 18. Now look at negative 12 or minus 12, and then we got minus 18. That's minus 30. Once you add those up, keep the sign that you're working with here. Those are my losses. I spent $30. So 18 minus 30. So here's your final rule 2 to take. Subtraction, 30 minus 18, that should be 12. Keep the sign of the larger integer, rule 2. So that same sign combined, if you did it left to right, well, negative 12 plus 16, that's going to leave me with positive 4. And positive 4 minus 18, that gives me a negative 14. And then add 2, we're going to subtract this. So negative 14 plus 2, we got to subtract, we end up with that negative 12. So whichever way you handle it, I hope you got these correct answers. We're going to move on right along here to rule 3. So we're going to look at integer rule 3 and what that entails. Okay, so let's go on and bring up my other screen here. We're going to share that worksheet that we talked about in the last video. Looking for it here. Okay, I found where I unfortunately I closed up that file earlier here, so we're going to go ahead and share that worksheet again here. Once again here, if you're your first time viewing my video here, this is a worksheet here for the 4 integer rules. It's on ordinary 8.5 by 11 inch paper. So if you provide me with your email, I can certainly attach this to your email, and you'll have this nice little worksheet to remember how the 4 integer rules work. We went over rules 1 and rule 2 in my last video. Now we're going to talk about rule 3. So what we're going to do here is when you subtract a negative integer, you will change the signs to plus, then follow rules 1 or 2 to complete the task. 12 minus a negative 3 becomes 12 plus 3. We're going to add those together, equals 15. And negative 6 minus a negative 9, we're going to change minus negative to plus. And then negative 6 plus 9, we subtract, we end up with positive 3. Okay, let's go on and take a look at some more examples how integer rule 3 is going to work. So again, we might have here 4 minus a negative 7. Rule 3 comes in when you have this combination here, subtracting a negative integer. Mathematicians came up with the notion, well, you cannot subtract a negative integer. This double negative ends up becoming plus, is what ends up happening. So minus becomes plus, and you have another plus over here. Sometimes you've seen this with your instructors say plus plus. Bring it down in the next line, and what we're going to do is bring plus 7 here. Now we're going to treat this as rule 1 or rule 2. In this case, 4 plus 7 is ordinary 11. Negative 9 minus negative 3. So you got to look for this. You got to recognize that we're subtracting a negative here. If this parentheses was next to the 9 here without any operation, that's multiplication. We're going to take a look at that a little later on. But right now, we have this minus sign preceded by the parentheses, and we have this negative 3 inside the parentheses. So this double negative becomes plus and plus. Make sure you leave negative 9 alone. Negative 9 plus 3. So again, here we have a left pointer, and we have our right pointer with the plus 3. This is rule 2 here, and that's what I meant by Finishing up with rule 1 in this case was our last problem. Here's our rule 2 in this case here. So 9 minus 3 is 6. And we're going to go ahead and keep the sign from the larger integer. That 9 is magnitudely larger and sharing a negative sign. So negative 6 is our final answer. Rule 3 comes up in different applications with formulas in algebra. Whenever you're subtracting variables, sometimes a variable has a negative input. And this is where the rule 3 is going to come up here. We're going to take a look at that in a later on video when we're dealing with different formulas. We'll follow up with a couple examples here that you're going to have a chance to work on. 12 minus negative 15. Negative 7 minus negative 5. Negative 8 minus negative 8. We're going to take a look at that one. That'll be interesting. And finally, 13 minus a negative 2. Go on, pause the video, give yourself a chance to do these problems. Okay, hopefully everybody got a chance to do these problems here. Let's go on and solve these here. Now you see this minus negative. This is the rule 3 that's got to take place. So what's going to happen is this becomes plus plus. And you have 12 plus 15, which equals 27. And it's positive. You get 27 there. Here we have this minus and negative 5 here. We're going to change that to plus plus. So negative 7 plus 5. In this case here we got rule 2 here. We got a left pointer and a right pointer. 7 minus 5 is 2. Keep the sign from the larger integer. And negative 2 is your final answer. So we got here negative 8 minus a negative 8, so negative 8. See, double negatives become plus. Put that up there so you saw what happened. In this case here, these are going to cancel out. Negative 8 plus 8, 0. Zero signless. Last one here, 13 plus 2, 15. So that's how you handle rule 3. Hopefully that clarifies how integer rule 3 is going to work. Sometimes in practice problems, booklets and teachers want to make sure you understand how rule 3 works. Rule 3 has to happen first in several integers. Let me put up an example here. Let's say we have 10 minus negative 2 plus 4 and minus 8. So before we can go ahead and deal with rule 1 and rule 2, we have to take care of rule 3 first before we can handle rule 1 and rule 2. So here's a rule 3 signature right there. Whenever we're subtracting a negative, notice that we're subtracting 8 here. This is not rule 3 here. We need to see that subtracting a negative. So here we're going to go ahead and change that to plus and plus. Rewrite the next line, 10 plus 2 plus 4 minus 8. Well, this is great news. It looks like we have all of our obtaining money over here. We just have that subtracting 8 in the end here. So 10 plus 2 is 12. 12 plus 4 is 16. 16 minus 8. It's going to be a value of 8. Final answer. So just remember, you do rule 3 first if it's present first in these kind of integer problems. And then go ahead and handle rule 1 and rule 2 as necessary. All right, that is the first 3 integer rules of our pre-algebra section. We're going to look at the last one. Rule 4. Integer rule 4. Let's go and bring up our worksheet. Integer rule 4. For multiply or divide only. Notice that I've highlighted this in red. Make sure you understand that. Rule 4 is for multiply or divide only. This is where the confusion can happen here when you see different things, and I'm going to show you examples what's going to happen when you see different things. You might say right away, oh, integer rule 4, or is it integer rule 1? Integer rule 4, multiply or divide only. When the signs are different, 2 integers at a time, the result is negative. Okay, let's go on and take a look what I'm talking about here. We've done this integer rule all of our life since the 4th grade. We just worked with half of the rule is what it is. And remember, it's multiply and divide only. We know 3 times 7 is 21. When you get into more advanced mathematics in high school, it's going to be written like this. Here we go. Look at the parentheses here. We've got a closed parentheses and an open parenthesis, and there is no operation in the center of it. This is a multiplication signature. So whenever you see parentheses, neck and neck, as I like to call it in my classes, that means multiplication. There's nothing else you do. You don't add, you don't subtract, none of that. Okay, let's go on and apply some examples of the sign integers. We've done all the positive ones pretty much since the 4th grade. Let's change the signs. So when I'm talking about signs are different, 2 integers at a time. Different signs mean one integer is negative, one is positive, or vice versa. So long as I see different signs here going on, I know my answer is automatically a negative. Now this one here, you're going to pay attention to. The only thing I did is I switched the negative onto the 7 because I want to talk about a very good point here that my classes have gotten incorrect from time to time, and this is how I can tell if the class is paying attention or not here. Signs are different here. In this rule, it's got nothing to do with the larger size integer. So I would ask my class, is the signs the same or are they different? Well, they're going to tell me they're different. And they tell me that the answer is going to be a negative, and then I will come back and ask them, well, why is the answer negative? And if the students are going to tell me, well, because the 7 is larger, that's when I stop them in their tracks and make that clear. That as long as signs are different, it's an automatic negative. It's got nothing to do with the size of the integer in this rule. Just keep that in mind whenever you're doing work on these problems or you see different things with the instructor talking about different signs. Got nothing to do with the larger integer. So 5 times negative 6. Again, signs are different. It's an automatic negative. Don't care that the 6 is larger. So what happens if the signs are the same? Negative 7 times negative 8. So if it's negative, if the signs are different, you get a negative. If the signs are the same, you get a positive. So 2 negatives in rule 4, multiply them together, becomes a positive. Just make sure that it's multiplication only. This is rule 4. Because what's going to happen is when you start looking at these rules in different problems here, you're going to start looking at this. Because I've had this happen here where the signs are the same and they're telling me that it's going to be a positive 15. Well, this is back to rule 1 because we have a negative 7 and we're going to subtract 8 here. This is back to rule 1. This is our 1. So you just got to remember that. Keep these rules straight and you're going to have no problems at all here. Am I multiplying and dividing? That's rule 4. Am I adding or subtracting? Look back in rule 1, 2, and 3. It'll have no problems at all. Sometimes we're going to have to multiply more than 2 sets of integers. So we get a positive 3 times a negative 7 times a negative 2. So what you're going to do is you're going to perform this left to right and you're going to work this 2 integers at a time. So I got a positive 3 and a negative 7. So if the signs are different, it's an automatic negative on the outcome of the answer. 3 times 7 is 21. So we're going to bring down negative 2 here in the final step here. Now the signs are the same. We're going to have a positive here, so that's going to be 42 positive, and that's going to be our final answer. So that's why I did highlight back on the sheet 2 integers at a time, because I've had different things happen where, oh, the signs are different, and this is an automatic negative. It's not, because this is 3 integers you're looking at. You got to take integer rule 4, 2 integers at a time. Then you get your final answer. Negative 1 times negative 3 times negative 4. Oh, the signs are the same. It must be positive, right? No. You're going to see that the final answer is going to be negative. So just remember, 2 integers at a time. Negative signs are the same. You get a positive result. 1 times 3 is 3. Bring down negative 4. Now we can see in the final multiplication, the signs are different. Positive 3 times negative 4, it's an automatic negative. Signs are different. Negative 12. Hope that clarifies integer rule 4 for us. So just remember, it's for multiply and divide only. I repeat that 100 times in my class because this is one rule that we like to apply for different things, and it's only for multiply and divide only. Negative 72 divided by 8. So now we can start making fractions. This is the same as this. Negative 72 divided by 8. These are the same. The first number goes on top, and the second number will go on the bottom here. When you look at this horizontally and you look at this in a vertical fashion. Signs are different. It's an automatic negative. 72 divided by 8 is negative 9. See? Signs are different. Automatic negative. Doesn't matter if the larger integer in this case here. Negative 10 divided by negative 2. Well, the signs are the same here. This is a little bit of old school here. Then 2 negatives are going to cross themselves out, become a positive here. You have positive 5. Signs are the same, positive. Back to 2 positive numbers. We've done this all of our lives. 18 divided by 3. Signs are the same, positive. We've done this all along here. Now we're just applying the different sign rules. So that pretty much covers integers rule 4. Give you a couple examples to work on. 9 times negative 1 times 2 36 divided by negative 4. Negative 1 times negative 2 times negative 1 times negative 3. 24. Make that negative, divide by negative 3. Pause the video, go ahead and work on these here. I will show the answers. Okay, hopefully everybody got a chance to work on these here. Well, positive 9 times negative 1. The signs are different. We have a negative, so negative 9. Bring down positive 2. Signs are different. Final answer is negative 18. This one here, 36 divided by negative 4 is only 2 integers at a time. It is 2 different signs. We're going to have an automatic negative. 36 divided by 4, negative 9. Take a look at this one here. Signs are the same. You get a positive here. 1 times 2 is 2. Positive 2. Positive 2 times will bring down negative 1. This is going to be negative. Signs are different. Negative 2. Bring down negative 3. Well, the signs are the same here. Get the positive. This one here, signs are the same. I can go ahead and do that there. 24 divided by 3, positive 8. This concludes our integer rule 4. Integer rules 3 and 4 were covered in this video. Please hit that subscribe button. Hit the like if you like what you saw in this video. And we'll see you in another video real soon. Have a good day.